So welcome back. Today we will look at the 4+1 view of architecture. Let us start with an example. All of you know about Linux operating system, for that matter any operating system. So what does it have? It probably has a process scheduler whose job is to handle the multitasking, schedule various processes and so on. It will have a memory manager which is trying to handle the memory requirements of individual processes, swap them in and out and so on. There is a file system which is interfaces with the hardware and provides you an abstraction of a file. There is a network interface which will connect you to the external world. There is an inter-process communication module. There is something about initialization, and there may be a library which allows you to compute some functions. So if you look at these subsystems of the operating system, we can depict them in this fashion. The Linux operating system consists of the memory manager, the process scheduler, the file system, the network interface and so on. This is a pictorial depiction of the same thing. We can take this further and say the file system consists of some smaller subsystems. There is a call level interface, there is a quota manager, there is a buffer cache and so on. Right. Now interestingly, if you try to see how these various subsystems interact at runtime, we get a slightly different picture. So the memory manager is talking to the file system, but it does not talk to the network interface. The process scheduler is talking to the initialization module. It does not seem to talk to the file system for whatever reason. The network interface is talking to the library, it is not talking to the inter-process communication module. So these arrows here are depicting runtime interactions. It may be a function call, it may be a blocked function call, or it may be making use of a service from in that other subsystem and so on. This is a process view of the subsystems that exist in the Linux operating system. If you break down the file system further, for example, its subsystems in the file system, which consists of the cache and driver and virtual file system and so on, they have their own interaction pattern. This interaction pattern is again unique in its own, and it is not hierarchic like in the classification we have seen just 2 slides before, right. So what we have seen just now is the Linux operating system can be described in 2 different ways. One in terms of what subsystems it consists of, and another in terms of how did these subsystems interact with each other at execution time. So these are obviously 2 different perspectives of the same functionalities, same program that we are running. So way back in 1995, Philip Cruchten is the one who tried to capture this in a very seminal paper called the 4+1 view of architecture. Philip Cruchten that time was with Rational Software. Right now he is a prof at University of British Columbia in Canada. He is a very well known person in software community, influenced this domain in many different ways. Many of you must have seen his book on the RUP, Rational Unified Process. So he is the first one to identify that software will consist of multiple perspectives, and he tries to say there are at least 4 perspectives. So he tried to give names to them, and then he wrote it up in a paper which got published in IIEEE Software in 1995. He calls it the 4+1 view of architecture. So what are the 4 views? The 4 views are the logical view, the process view, the implementation view, the deployment view. All these 4 integrated together with what is called the use case view. Logical, process, implementation and deployment. These are the 4 views of a software architecture. So this is a simple description of the 4 views that exist. We will try to see what do these mean. So the logical view basically talks about how is the system decomposed into its constituent modules. In some sense it is a logical level decomposition. What is the functionality in that subsystem? That is what the logical view is all about. The process view tries to see, identify what are the execution time components, what are the runtime components, and how they interact with each other. The physical view, which actually describes the runtime components and how, on what kinds of hardware, on which computer system each one of those components is deployed. It is basically a deployment view. And the development view talks about which component is sitting on what file, what is the name of the file, and or which team is developing, sitting where, what kind of subsystem, and so on. That is the development view. It is obviously important for project managers. So these are the 4 views that have been identified: the logical view, the process view, the physical view, and the development view. And use cases or scenarios are the ones which stitch up all these views and describe the functionality. So this is the theory by, or hypothesis by Philip Cruikshank, and this has in fact become the basis of all software, all frameworks for software architecture description. So I have a simple example here which describes these 2 views more clearly. Let us say I am looking at a small program whose job is to accept a stream of characters as input and produce a new stream of characters identical to the original one, but with the uppercase and lowercase characters alternating. So the first one should be uppercase, followed by the lowercase character, by a lowercase character, then uppercase, lowercase, and so on. Okay. So take a stream and keep changing the case of the input stream and output that. So that is the program. So let us look at the process view first. What will I do? Once the input comes here, I am going to split it into 2 parts. I will send one to this module, and it is going to convert whatever the case of the input character is into uppercase and send it here. I will take the next character that comes and send it to this module, which will convert it into lowercase and push it here, and this merge module is going to pick one character from here and another from here alternately and output it. This is going to give me an output stream which is identical to the input stream, except that the first character is always uppercase, second is lower, third is upper, and so on, right. So I am talking about the components that will realize this and how they are going to talk to each other at execution time. I can describe the same happening, the same piece of software in a different vocabulary. I will say I am interested in a program, and this program is going to consist of 2 components, one which converts everything to uppercase and another which converts everything to lowercase. There is another subsystem which takes in the input stream and splits it into one uppercase and one lowercase, and finally there is a subsystem which merges these 2 streams. So this is a description of what are my subsystems. This is a description of how these subsystems are going to interact with each other. So this is a logical view of the program which executes, which realizes, recognizes this functionality. This is a process view of the same program which delivers the same functionality. Okay. I hope this is clear, the difference between a process view and a logical view. Okay. Now let us try to build our own example, our friendly, well known, familiar library system. Now what we want to do is to, let us say, automate the library. So what does the library system consist of? The library system will have probably a catalog module, right. It will have a circulation module. It will probably have an acquisition module, By this I mean where you buy books. This is the module which you use to buy books. It will have probably a module to manage journal subscription. Normally these two are two different modules because they have different business logics associated with them. And of course we also have a user registration module, where we identify who are the valid users, what are their privileges and so on. So my library system consists of a catalog module, a circulation module, a user registration module, a journal subscription module and a book acquisition module, right. So what view is this? This is the logical view of the library subsystem. Now let us see how these various subsystems interact at runtime. So if we want to issue a book, the circulation module is the one which will issue the book. It is going to talk to the catalog module and to the user registration module, right. It should know details of the book that is being issued, that comes from the catalog module. It should know what are the privileges of the user, how many days can I issue, how many books I can issue and so on. That is in this user registration module. Probably this has a database connected with it, but let us not worry about it. Now if I want to buy books, that is the acquisition module. It is connected to the catalog subsystem because it first it has to make sure that the book I am buying is not already in the library, and after it buys a book it enters the information about the book into the catalog subsystem. So similarly, if you have the journals subscription module, that is also connected to the catalog subsystem, right. So these are the processes that are likely to be there in a library subsystem, and this is how they will interact. The diagram is different from this diagram, right. Now and what is this? This is the process view. There is more to it. Let us say I would like the catalog to be visible all over the internet to the public. So I will put it on a machine which is accessible from outside the world, outside my, let us say, firewalls or on a public IP. So what I would have is, let me change the color of this pen. I would have the catalog module sitting on one machine, the circulation sitting on one machine, and possibly these three subsystems is sitting on a different machine. These are accessed only by the library personnel inside the library, because there are financial issues involved, there are user privileges involved. They may not be, I may want to put them in a slightly more secure area, not accessible to the regular user. So these 1, 2, 3, 4, 5 processes are deployed on 3 different machines. So when in this diagram, what am I depicting? I am depicting which process is sitting on which machine. So this is also a perspective which is needed for the complete description of what the library system is and how it will run. So this depiction is the deployment view or the physical view or whatever you want to call it. There is a little more to it. You might decide the catalog subsystem is being developed at Kanpur. These two are being developed at Mysore, and this is being developed in Delhi. I might have a development model like this. So, this is also a piece of information which is required for the managers, and it has to be stored somewhere and it will be processed in different fashion. So, this is yet another perspective of the software which is needed for the complete description of the software development, complete description of the architecture as we call it. The use cases are not specified here, but we understand what use cases are. There may be a scenario where one user will come, go to the circulation module, produce a book, produce an identity card, and so on and so forth. That is the +1 view. But the process view, which talks about what are the runtime entities, the deployment view, which talks about on what machine each one of these processes is sitting, and the development view, which one is, who is developing which module, and of course the functionality itself described as a logical decomposition is the logical view. So, these 4 constitute the 4+1 view of architecture. Now, what I would like you to do as a homework is, next time you see any architecture diagram, these are box and line diagrams or boxes and arrows or whatever you want to call them, you would see them everywhere. Try to see what kind of information they are trying to depict. Are they giving a logical decomposition of the functionality, or are they talking about what are the components and how they are interacting with each other, or which component is sitting on what piece of hardware, and so on. So, if you practice this, then you will quickly realize that these diagrams that we draw are actually quite complicated. You would often find the process view and the distributed the deployment view together. The processes and on which hardware it is being deployed, on which hardware it is going to run or it is running, they are shown together. So, they may be drawn together, but you try to develop an eye for what is this diagram talking about, which one of these views. We will see this in greater detail in subsequent lectures, where we talk about how to describe architectures or how to document architectures. As I said, the 4+1 view was a seminal paper. It is the one which has influenced how documenting architectures theory has developed subsequently. Thank you.